A very good morning. I bid to Dr. Azina binti Abdul Razak. Today we will present about assignment engineering mathematics 2. The application is implicit differentiation and related rates. Okay, our title given for this assignment is how fast is the rocket rising from the earth and the elevation angle of a radar toward rocket. Okay, this is our company organization. Our company given name is Yes Radar Communications Sdn Berhad. Okay, for our director manager is Muzaki Hakimi. Our project designer is Muhammad Fidaus. Our project engineer is Muhammad Haziq. And me myself as secretary Angkana. Okay, I will start with introduction. Up to now, we have dealt with function expressed in the form of y equals to fx. That is, function in which the dependence variable y is expressed explicitly in terms of independent variable x. However, now all functions are expressed in this form. Some equations are expressed implicitly as a function of x. For example, y to the power of 4 minus y to the power of 3 minus y plus 2x to the power of 3 minus x equals to 8. We can find the derivative using implicit differentiation. Okay, implicit differentiation. We need to assume that dy over dx exists. Finding dy over dx by implicit differentiation. Okay, first, differentiate both sides of the equation with the respect to x. Make sure that the derivative of any term involving y includes the factor of dy over dx. Okay, second, solve the resulting equation for dy over dx in terms of x and y. Okay, next is related rate. Okay, related rate tells us that implicit differentiation is a useful technique for solving a class of problem known as related rate problems. In related rate problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another quantity, which may be more easily measured. Okay, now I will share about solving related rate. Okay, solving related rate problem. Okay, first assign a variable to each quantity. Draw a diagram if needed. Okay, second, write the given value of the variable and their rates of change with respect to t. Okay, third, find an equation giving the relationship between the variable. Okay, fourth is differentiate both sides of this equation implicitly with respect to t. Okay, 5. Replace the variable and their derivative by the numerical data found in step 2 and solve the equation for the required rate of change.
Now, the application of implicit differentiation can apply especially in radar and rocket system. So, by using the implicit differentiation and related rates problem, in this situation, we know how the fast is the rocket rising from the earth and also know how much is the elevation angle of radar towards rocket. Before that, let me introduce background of Soyuz rocket and the Moroba radar system. The Soyuz launch from the Guiana Space Center or CSG will place its satellite passenger into Sun Synchronous Orbit or SSO. The launch will be carrying a total payload of approximately 1,340 kg. Soyuz is used for manned and unmanned flight to the International Space Station, as well as Russian government launch and commercial launch. The first launch of the Soyuz 21A version on November 8, 2004 from the place Kongdron represent a major step in the Soyuz launch vehicle development program. Then, about the Moroba radar system. The Moroba radar is located 50 km from the Soyuz rocket launch pad. This radar provides the Range Instrumentation Radar RIR 774C, a highly mobile and accurate C-band 5.4 until 5.9 GHz monopulse single target tracking radar. Last one, the Moroba radar used to determine the range, angle and velocity of the rocket. The diagram shows the relationship between rocket and radar system, where y equals to 4,000 meters and x is equal to 5,000 meters and z is unknown. Now I will share the video how to construct the rocket and radar system in AutoCAD software.
Now let me see how the implicit differentiation can be related to this type of application. As we can see from the question, it provides the distance between Moroba radar and launchpad, that is 5,000 meters, and it also provides the altitude of the Soyuz rocket from the launchpad, that is 4,000 meters. And the last parameter given is the distance between the rocket and radar, that is increasing by 300 meters per second. So that means at x-axis the value will be 5,000 meters, at y-axis will be 4,000 meters, and value z against time is 300 meters per second. So from all the value given, question asks to find how fast the rocket rising from launchpad. That is different in y-axis against time. So as the formula for Pythagoras theorem, that is x squared plus y squared equal to z squared, we will differentiate each of the value respectively. Since the value at x-axis is remain constant, by differentiate x against time we'll get 0. For y squared, differentiate we'll get 2y dy over dt, and z squared differentiate equal to 2z dz over dt. Then we will choose dy over dt as our subject. So 2y we will move to the right side, and we will get z over dy times dz over dt. Then we will substitute z value into square root x squared plus y squared, and the value given from the question we will insert into x, y and dz over dt. And from the equation, you will get dy over dt is equal to square root 5,000 squared plus 4,000 squared over 4,000 times 300. And the answer, we will get 480.23 milli per second. For the next question, it asks us to find the elevation angle of radar towards the rocket. So the formula we use is tan theta is equal to opposite over adjacent. So theta, we will get 38.66 degrees. For question C, it asks us to find d theta over dt. So from the previous question, we get our dy dt is equal to 480.23 millisecond and theta is 38.66 degree. So for this question, we will start our step with differentiate tan theta is equal to 1 over x, that is 5,000, with times with dy over dt. So differentiate tan theta, we will get sec squared theta, that is equal to 1 over cos theta squared. So we put our value for dy over dt, that is 480.23 millisecond, into the equation. So we will get 1 over cos theta square d theta over dt is equal to 1 over 5,000 times 480.23. So we put our d theta over dt as our subject, and 1 over cos 38.66 squared will move to the right side, and we will get our d theta over dt is equal to 0.0585 radian per second.
Okay, next, how to find the different values of how fast is the radar elevation angle when rocket rising at altitude of 4,000 meters and 6,000 meters. Okay, firstly, we need to determine the value of dy per dt when the rocket rising at altitude of 6,000 meters. So now we apply the Pythagoras theorem concept, which is s squared plus y squared equal to z squared. Okay, now we differentiate value of s squared, y squared, z squared to the time, which is d over dt. The s squared d per dt become to 0 because the distance of s are constant, means it does not change with the time. Then the y squared d per dt become to 2y dy per dt, and z squared d per dt become to 2z dz per dt. Okay, now, how to get only value of dy dt? So we need 2z must be divided by 2y and multiply it to dz per dt. So we can cancel out of 2z over 2y and got z over y. Then replace z by equation of square root of s squared plus y squared. Then divide by y and multiply with dz over dt. Put the value of s equal to 5,000 meters and y equal to 6,000 meters, and dz per dt is 300 meters per second. Then we calculate it. We got dy over dt is 390.15 meters per second. Okay, now, how to find the elevation angle of radar when the rocket rising at altitude of 6,000 meters? Okay, first, tangent theta equal to y over s. where the y equal to 6,000 meters and divide by s equal to 5,000 meters. So we shift tangent answer and got the total is 50.19 degrees. Then find the how fast is the rudder elevation angle when rocket rising at altitude of 6,000 meters. Okay, firstly, we need to differentiate of tangent theta equal to 1 over s or 1 over 5,000 meters dy per dt. The differentiate value of tangent theta is equal to sec square d theta per dt equal to 1 over 5,000 dy per dt. Sec square must be convert 1 over cos theta and equal to the 1 over 5,000 dy per dt, where the dy per dt is 390.15 meter per second. So we calculate its value. We got the d theta per dt equal to 0.032 radian per second. So now the different value of d theta per dt when the rocket rising at 6,000 meters and 4,000 meters is negative 0.265. Okay, the negative signs mean the speed of rudder elevation angle between the rocket rising altitude of 4,000 meters to 6,000 meters become decreased or slower. Okay, in conclusion, we learn how to apply implicit differentiation to the engineering field, especially in radar and rocket system. And then we learn how to solve the problem of related rates. In this case, we know how to calculate the speed of rocket and speed of radar angle elevation. And lastly, we learn the relationship between the radar and rocket. Thank you.